Welcome to CEDA-Labz. In this PPT, we will show you the download procedure of Xilinx software, and also some basic implemented codes. The process the development software goes through to compile a design into a bitstream. Here's what happens. You enter a description of your logic circuit using a hardware description language, HDL, such as VHDL or Verilog. Or you can also draw your design using a schematic editor. Or you can use a combination of the two. A logic synthesizer transforms the HDL into a netlist. The netlist is just a description of the various logic gates in your design and how they are interconnected. A schematic is already pretty close to a netlist, so it doesn't need as much work done on it as the HDL code. The implementation phase employs three different tools. A translator merges together one or more netlists along with any design constraints. This is fed to a mapper that combines gates in the netlist into groups that will fit efficiently into the LUTs of the FPGA. The gate groupings are sent to the place and route tool that assigns them to LUTs at various locations in the FPGA and then determines how to connect them together using the routing resources, wires, in the switching matrix. This part takes the most time, as finding a placement that can be routed efficiently requires a lot of computation. A bitstream generator takes the output of the implementation phase, combines it with a few other configuration settings, and outputs a binary bitstream. This bitstream, which, depending upon the size of the FPGA, can be many megabits in length, contains the truth tables that will be loaded into the RAM of every LUT and the connection settings for the wiring matrix that will connect them. At this point, a bitstream is just a bunch of ones and zeros in a file on the computer. The downloader will transfer this file into a physical FPGA chip. In most cases, this chip is already mounted on a circuit board, where it waits for the bitstream that will make it perform its intended function. Xilinx develops and sells their ISE FPGA tools, and they also distribute a free version called Webpack. Webpack won't generate bitstreams for the really large FPGAs, and it lacks some special function design tools. That will be more than sufficient for this tutorial. To get Webpack, just do a search for Xilinx Webpack download. Use Google or Bing or any browser. If you click on the first link you get, it will probably take you to this page. Click on the Download ISE Webpack software for Windows and Linux link and it will take you to the main Xilinx Downloads page. Click on the ISE Design Tools tab and then click on the link for the latest version of ISE, which is 14.7 at the time I'm writing this. Now scroll down the page until you find the section for the full product installers. Click on the link for the full Windows installer. Before the download begins, you will be presented with a sign-in screen. If you don't already have a Xilinx account, you will have to create one. Then sign in using your ID and password. Then you'll have to go through a screen that verifies all your contact information. Click on the Next button at the bottom and you'll get to a screen which describes the benefits of the download manager that you'll have to install to get Webpack. A pop-up window will appear so you can grant permission for the manager to run. Just accept the fact that this is the way it's done and click on the Run button. Now be prepared to wait an hour or two for the download to finish, as the file is of about 6 gigabytes. Feel free to watch the progress bar creep toward 100%. After the archive is downloaded, you can unpack it and run the installer, xsetup.exe. You'll go through a couple of screens where you have to accept license agreements, and then you'll reach a screen where you have to select what software to install. Make sure you choose the Webpack edition, unless you want to pay money for one of the others, or are willing to accept a time-limited license. Also make sure to select the option to get a license key. Yes, you will need a key even though Webpack is free. The Webpack license is not time-limited, so it will never expire. Next, select a directory for holding the Webpack software. I usually choose one that's close to the root of my hard drive and doesn't have spaces in the name, just to avoid troubles later on. I also add ISC to the name that appears in the Start menu, to distinguish this software from Xilinx's Vivado suite of tools. After clicking on the Next button, a window appears that lists all the installation options you've chosen. Click on the Install button and then sit back for 45 minutes or so. When the installation is almost done, you'll see the screen appear. Select the Webpack license as the one you want to get and click Next. Then you'll get a screen showing the information that will be associated with your license. Click the Connect Now button to start the license generation process. Once you do, your browser will open a window to Xilinx, and you'll have to log in using your account information again. Then you'll have to verify your contact information again. Finally, you'll get to this screen. Select the ISC Webpack license checkbox and click on the Generate Node Lock License button. Next you'll see a couple of confirmation screens like the following. Under System Information, select some identifying characteristic of your PC that the licensed software can use to lock the Webpack software to the PC. After clicking the Next button in the final confirmation screen, you'll get an acknowledgement that your license has been emailed to you. Once you've received the email, there's a bunch of instructions for how to install it. You can follow those directions or take the easy route, just drop the license file into the C/Xilinx directory created when you installed the software, assuming you installed it to your C drive. Then the ISC software will automatically find the license file when it starts up. You can also click on the Finish button in the final window of the ISC installer. You probably forgot all about that by now. Now coming towards the codes. This is the example of basic AND gate. It is written in all three types of modelings. This is how a program is written in Xilinx. You can write it in the previous way too, as we used to write it. Here, it is just that the definition and declaration is done at the same time. And here is the user constraint file for the program. Before you can pass the synthesized netlist through the implementation tools, you'll need to tell them what pins of the FPGA will be used for the input and output ports of your code. Otherwise, the tools will just assign them to any pins it deems fit for the purpose. An implementation constraints file, sometimes called a user constraints file or UCF, is used to assign input-output signals to the FPGA pins. For the pins, you can refer the reference manual of the device. Here is the combinational logic implementation code of 8-bit comparator. And here is the user constraint file for the same. As you can see, each and every vector bit is allotted a pin. Here is the sequential logic code implementation of JK flip-flop. And this is the user constraint file for JK flip-flop.